Yep, the recording is started. So we're talking about the DHCP protocol, and that is one of the most used protocols in local networks. The origins of this protocol, they lie in 1984 or 85, I don't remember exactly, when another protocol was introduced. It was the Bootstrap protocol. And the origins of the Bootstrap protocol, they are in totally ancient times in 1960s. You know that the initial goal of this protocol was not to pass the IP addresses to everyone. It is like a side effect right now. So now it is the main purpose, but it is a side effect of the initial idea of the HTTP protocol. The initial idea was to pass the configurations to the terminal stations in the in very closed environments. The center of this environment would be the mainframe computer, so a big computer, and the terminal stations that did not have the opportunity and that did not have the capability to store the files of the operating system. So they had to receive the operating system files and the configurations each time they boot up. That is why the Bootstrap protocol was invented in the first place. I'm sorry. And why didn't the terminal stations have such an opportunity? It was because the reliable and compact hard drives haven't been yet invented. And so in the late 80s, there was a mass production of the hard drives, the drives that are called the HDDs now. So they appeared the opportunity to store the operating system and so on. But initially, the HTTP protocol, it handed over the configuration files and so on. And this capability still remains with the DHCP protocol. So you may configure all the ZTP, which is the zero-touch provisioning on our switches as well. But the main purpose of the DHCP protocol right now is passing the IP addresses and subnet mask. But still, the DHCP protocol has still around 2055 options and 255 options, and each option may be used to pass some information. However, this protocol is completely insecure. It doesn't have the authentication capability. It doesn't have the verification capabilities, any of them. So the DHCP client cannot... Why is that? I'm sorry. Okay. Okay. So when the, as I said, that yeah. Name is Serbian, like Slavic languages. We have a lot in common. So some people ask me, okay, you will make the training for Serbia. Why don't you do it in Russian? I said, oh no. It's better to speak English. The language differences, I wouldn't explain, but still, yeah. Okay, so the DHCP protocol is the client and server version of the protocol, and mainly in a nutshell, and in its very essence, there are just four messages that are transferred from client to the server and back. So the first messages that is sent from client to the server is the DHCP discover. And it is sent in a broadcast mode. Why in broadcast? As I said, the DHCP client doesn't have IP address. It doesn't have any notion and any thought about whether the server is present in the network. So the first discover message says like, can anyone give me any IP address? Please help me. I don't have any. So the DHCP server receives this DHCP discover message and then answers with the unicast. In most cases, it is a unicast message, but it depends. So if the client asks for the broadcast offer message for broadcast reply, the server will use the broadcast reply. There's a special flag in the broadcast message, which is called the B flag, broadcast flag. So if it is equal to 1, not to 0, then the offer will be transmitted in a broadcast manner. But if the broadcast flag is 0, then the offer will be transmitted in unicast manner. So here on our schemes here in this chapter, the red arrows represent the broadcast messaging, and blue arrows represent unicast messages. So when the offer is sent, the DHCP server indicates the IP address that it is ready to give to lease the client. The DHCP server is giving the addresses not for the permanent use, but for a lease, for temporary use. And also in the offer message, the DHCP server indicates his own address, so its own address, as a server identifier. So the field is called SI other, C other. Then when the client receives this DHCP offer, he says, okay, this address is okay for me. I like it, so I request this very address. And so the next message will be the DHCP request that is sent as well in a broadcast manner, so that all the possible DHCP servers of the network understand that, and the client in this DHCP request message, it indicates the identifier of the server that it wants to get the address from, so that all other servers should have this DHCP request message, see the identifier. If it is not there, they just drop the session and just don't do anything, and then return the IP address to the pool, back to the pool. Yes, as I said, the server gives the addresses, gives out the addresses from the certain pool of addresses, not just any IP address, but the address from the certain pool. After that, when the server receives the DHCP request, it understands that right now he has an obligation to give this IP address to someone, to some client, and so he gives the address out. He books this address, and so he will issue the. It will combine the so-called DHCP binding table, where he says, okay, the client MAC, like here it will be MAC A, will have the IP like 10.10.05 right now. And so he indicates this address in DHCP ACK. ACK is from English acknowledgement. And so he acknowledges this address and also the list time for which it gives the IP address out there. Where we are, here we are. So when the time comes, upon receiving the DHCP ACK, the client configures 3 timers. The T0 is the timer halfway to the list time. It is 50% of the list time. Then T1 is 87.5% of the list time, and T is the list time itself. So when it comes to the T0, when the half of the time of the list time passes, the client says the unicast DHCP request message to the DHCP server saying, okay, I like this IP address, please give me this address, please let me use this address for the same time more. And the DHCP server says, okay, there's no problem, I will give you the ECK, so it sends the acknowledgement message, and then the lease prolongates to the same period. Starting from the ECK time, starting from the time of receiving the ECK. So if the client doesn't get the doesn't get the ECK from the server, and we know that it can happen, everything can happen with the server, so it can be switched off. There could be some works going on with the server with the system administrators, or it can be down, or it can be moved to some another address. So a lot of things may happen to the server. So it may not reply in time. So the DHCP client waits for the timer T1, which is 87.5% of the list time, and then sends the DHCP request broadcast message saying, can anyone confirm me this IP address, please? If there is any DHCP server on the network, it confirms the address and so sends the ECK. If not, like RFC says, the client should repeat the attempt of DHCP request reasonable amount of times, so reasonable number of times. But at least 4 times. So at least 4 times this broadcast DHCP request is sent, and then the client says, okay, I should say goodbye to this address. I liked it very much, but our destinies differ, so I have to part with it. And then when the T time comes, then it goes into with the DHCP discover to get some other IP address. Also, there are 2 more messages. 3 more messages. Yes, 3 more messages in the DHCP exchange that we don't give it here on the slide, but you have it. You have them in your student books. So in your student guide, which are the messages? So first, when the DHCP server is confirming the address here after the DHCP request, it may perform, but it doesn't have to, but it may perform the check of this IP address via the ICMP message. So the DHCP server pings the address that it is going to give to the client. For what purpose? For the purpose of checking if this address is already installed on the network by someone has manually configured this address. If there is no reply, no ICMP reply, no echo reply, sorry. If there is no echo reply, then the address is not installed. It may be given to the client. So the message ACK is sent out. If there is a reply from ICMP message, with echo reply. So it means that this address is used somewhere in the network, and so the client, the server says the client the NAC message, not acknowledgement. So the NAC message say, okay, sorry, I really was going to give you the address, but life is hard, so you have to go with the DHCP discover again. And so DHCP client goes with the DHCP discover again without having the address from the server. Another two messages are from the client. The first message will be sent right after the ACK. So sometimes, as the DHCP server uses the ICMP, it may have the reply, it may have the actual reply from the workstation having the address that it is going to give to the client, but the reply would come after the ACK is sent. So after the sending the ACK. It may happen in the network all the time. It happens all the time. As the ICMP protocol is not really a rapid one, and the DHCP server may be in some, maybe located in some other network. That is why it uses ICMP. But after the client receives the DHCP ACK, it is sending the so-called GARP message. It is the actually it is the ARP request, but the gratuitous ARP, saying that this endpoint, which is the DHCP client, now has this IP address. If no one has this IP address, please don't reply. But if anyone has this address, please reply. And if someone replies here, then the client understands that it should get rid of this address, and it should inform the server that the address is wrong. The address is already present somewhere in the network. And so it sends the message DHCP decline, which means I refuse of your filthy address. Sorry, nah, not gonna work. So it is the DHCP decline message. Also, there is one more message from the DHCP client. When user switches off the interface or switches off the DHCP address processing on the interface. For example, you've got in a Windows, you've got a tab saying automatic IP address or manual. So if the user turns off the automatic IP addressing, then the DHCP client sends the DHCP release message. So, like, of course, it says like to the DHCP server, it says like, I no more need, I don't need your IP address anymore. You can use it to wherever you want, give it to whomever you want. So thank you. I don't need it. So this is like what the messages are like in DHCP. Also, you see that we use the broadcast addressing, the broadcast transmission. That is going everywhere in the network. So there may be problems that some malicious people, malicious persons would receive this message and then send back some bogus DHCP offer or bogus DHCP ACK, and the clients will still configure these bogus addresses, the fake addresses, I mean. And then we're gonna have trouble. But we will study and we will consider some techniques like DHCP snooping or ARP inspection that are that have the purpose of getting rid of some malicious actors and preventing the problems that they may cause. But now let's concentrate on the DHCP server configuration in our network. So our switches, not all of them, of course, but some of them support the DHCP server functionality. These are mainly, so where should it be configured? So we have the access switches and the distribution switches. This is our usual topology of the network. So where should we configure the DHCP server on the switches? First option is the distribution layer, where we can configure the switches. Why here? As here, most of our VLANs are terminated. So, here, for example, VLAN 10 or VLAN 20 or so on. So all these SVIs with the default gateway addresses, they will probably be at the distribution layer. So that is where the DHCP server is very convenient to be placed. But sometimes we also can place the distribution, the DHCP server functionality on the access layer switches. Not on all of them, of course, but for example, at 2300 series, it is quite okay. Why here? We would use the DHCP addressing here at the access switch for the, not for the end client, of course, but mainly for the access points. It is very convenient so that we don't stretch the default VLAN to the distribution layer. It is not really as we mentioned yesterday, it is not really secure, but for automatic configuration of the access points, sometimes it is necessary that they are in the default VLAN and so on and so forth. So it is really convenient to place the DHCP functionality for the access point on the access layer. Give it the IP address, give it the address of the SAN controller that is somewhere in the network, and so on and so forth. Yeah. So for such devices like access points, like IP phones, the DHCP functionality on the access layer is convenient and comfortable and even expedient to configure. Okay, how do we configure the DHCP server? First, we should switch on the IP DHCP server functionality on the global configuration layer, in the global configuration mode. Sorry. Then we should configure the pool, the collection of the IP addresses that will be given to the clients for the release. At 2300 series, we have the IP DHCP pool network and the name of the pool. In fact, on this series, we have two kind of pools. First, it's the pool network, and the second is pool host. The pool host we will consider a bit later. The pool host is intended to giving up the static DHCP IP addresses so that the endpoint with one MAC address would always get the same IP address. Yep. So sometimes this functionality is necessary. But so IP DHCP pool network and the name of the pool. And at the 2400 series, there are just selected models that support the DHCP server functionality. There are 2424, 2424P, 2448, I think 2448P. So the beginning models are not supporting the DHCP server functionality. So the IP DHCP pool and the number. The main identifier of the pool will be the number of the pool, and name. But name is more like a description or the just a command here, not a command but command. Yeah, commentary. Then we should in the DHCP pool configuration mode. We should configure the actual address pool, so actual collection of addresses. We may indicate all the network, which is on the 2300. We use the address commands. But here we may state the network address and the subnet mask. And so we will use all the network. Or we may use the address and network address, like 10, 10, 1, 0. Then, no, it won't be like that. Sorry. Yeah, 1, 0, 24. This is one way. Another way is address low 10, 10, 1, 15. High 10, 10, 1, 50. And so our pool will give only these 35 addresses from 115 to 150. And also after that we'll say the mask 24. That means that all 25. That means that they are or whatever subnet mask you need here. Yeah, that means that these addresses will be given the mask 24, 25, whatever. Yeah. Okay. In 24 series, 2400 series, we use the network command. First would go the network address or the lowest address. So the syntax will be a bit different, like network 10, 10, 0, 15, 24/24, 10, 10, 0, 50. Yeah. So first goes the lowest address, then the subnet mask, and then the highest address. Then we should indicate the default router as we are on the switch, and as we use the switch. The default router may be different from what we got on the switch itself. So you've got the distribution switch. Yes, they may coincide, the default router address and the actual DHCP server address. But if we are on the, for example, on the access layer, then they may differ. So the default router and the IP address, the default gateway, I mean. Then DNS server with a dash. This is like, it should be like a single word. And then goes the IP address list, separated by the spaces, up to 8 addresses you may identify in one record. Okay, then goes the list, the days, hours, and minutes. You may identify any number of hours and any number of minutes, so it will translate the number into days and hours and so on. So the default value, it is 24 hours, 1 day. So that's what we need to configure. With the example here, okay, so as we used to see on our first day, it always an IP DHCP client configured on the VLAN 1. So we'd better get rid of it. So like we go to the VLAN 1 interface and say no IP address DHCP. So it doesn't interfere in the DHCP process. Then turn on the DHCP server, then IP DHCP pool network with some name. Also make the lower address and the highest address and the subnet mask. As I said, you may use the abbreviated prefix length here. Then default router, alias, DNS server, and so on and so forth. And then we go to the interface where the IP discoverers will be. So, for example, if we want to distribute these addresses, so this pool is for VLAN 10, then they go to the interface VLAN 10 and install the IP address that will belong to the network indicated here. Not to the range of address, but to the network. Like here, we know that the network will be 10.0.1.0.24. So here the address should belong to the network, not to the pool, but to the network. And so we'll go to the access port, switch port, and then configure the access VLAN here. Yeah. In 2400 series, almost the same, except the network command is used instead of address command, and the order of the addresses is slightly different. Not we don't use the low and high subwords, subcommands, but we just indicate first the lowest address, then the subnet mask, and then the highest address. The list, DNS server, and the default router commands are the same as on the 2300 series. What about the host pools that I mentioned earlier? The host pool is determined for disseminating the IP address directly to the endpoints with the known MAC addresses. For example, there are some kind of endpoints, like it may be the mobile teleconference things, like I don't know, WebEx board. If something, if we know what we are talking about, or something like that. So they're big, but and they can be moved between for example, the conference rooms and so on. But you would like to, in terms of security or in terms of some policies, you would like them to have one single IP address everywhere in the network. So you can make this host and tie the IP address to the hardware, to some hardware address, or either to hardware address, which is MAC address in essence, or the 32 byte or 32 letter client identifier that is used in Microsoft IDE or in Windows and so on. This also can be used. So we have here two pools. One for the address of ABC, so it is just completely bogus address, and it will gonna receive the address 101.150. So this is just for fixed addresses. And about the 2400 series, then you should use also the separate pool of the addresses. But here but actually you may use the common pool just to disseminate the addresses to the MAC addresses. Here the logic is slightly different, so you use the network command, the network address, and the subnet mask, or prefix instead of the subnet mask, like here. And then use the command host hardware address and IP. So you just make the manual matching of the hardware address and the different options like IP address or NTP server or DNS server, etc., etc., etc. The DHCP client is configured the same way on all the series of switches. So you go to the IP as interface, or the day3 interface, and then use the command IP address DHCP, either on 2300 series or on 2400 series. It's going to be the same. But to get rid of the IP address received by the DHCP protocol, on 2300 series, you should use the command no IP address DHCP. That terminates only namely the DHCP IP address received by DHCP. But at 14 or 2400 series, there is no such an option, just no IP address, so that all possible IP addresses will be deleted. Okay, this is what I want to tell you about the DHCP servers. Any questions, please? Yeah, thank you. So let us then continue with the DHCP relay functionality. This is also a very important feature of the DHCP protocol and the DHCP process. The DHCP relay is used somewhere where when the DHCP server is not present in the same broadcast domain with the DHCP client. As we said, the DHCP protocol is a broadcast protocol, so it uses a lot of its messages are sending broadcast transmissions, but if the DHCP server is another network or in another VLAN, which is the same, as essentially the VLAN is a separate broadcast domain. So if the server is in separate broadcast domain, then the DHCP discover message cannot pass through, and it cannot be delivered to the DHCP server. So we need the retranslation or the relay process. How does it work? For this purpose, we will need a switch, for example, the access switch, where our DHCP client will be connected. And on this access switch, we would have two interfaces. One is for the network from which the DHCP client would be sending the DHCP discover, and upon which the DHCP server will consider the IP address of this interface to match the exact pool from where to give the IP addresses, and another interface should be in the network in the VLAN where the DHCP server is located, or at least it should have this another interface should have the capability of making the L3 connection, layer 3 connection to the server. It should have the layer 3 connectivity, network connectivity. So how does this process work? In the VLAN, in the access VLAN, the DHCP client sends the DHCP discover message. It is a simple DHCP discover message sent by the broadcast. As I said, red arrows represent the broadcast and the blue arrows represent the unicast messages. So as you see in the DHCP relay section, all the messages are unicast, but in just DHCP section, ordinary DHCP section, or there are both broadcast and unicast messages. So the switch would receive this discover message, and then it would change the addressing of the message so that it looks not like a broadcast frame, but so it looks like a unicast frame, and inside it there will be just ordinary unicast IP4 IP4 packet with the payload of the DHCP options. So our access switch will have this broadcast message, change the addresses, and send it to the server with its own name and with its own addressing. But it will also consider it in a gateway and indicate its own address, like here, in the G address field of the DHCP packet. Yeah. Then the DHCP server would receive this discover message, go to this gateway address section, so see the address, look for the pool that is corresponding to this IP address, and then choose some of the addresses, and then consider make the offer messages that would be sent to the access switch. The access switch would then readdress the message, so change the IP addresses, change the MAC addresses to the DHCP client, and then it will send it like a normal DHCP offer with the identifier 1010. So the identifier of the DHCP server stated in here. So after that, the DHCP request will be sent from the client. Also on the switch, it would be readdressed. So the addresses in the layer 2 header and in layer 3 header, they will be changed to those of the server. And then the server will reply with the ACK message, and the client will receive the simple ordinary acknowledge message from the DHCP relay switch. So what should we do? And also there are sometimes the situations where we don't have the IP address for the lower part of the network. So we don't have the IP address on the interface of the client network. What should we do that in this case? In this case, we employ so-called option 82. The option 82 adds two parameters to the DHCP discover message and to all the messages that will follow. One of them is the circuit ID, and another one is the remote ID. The remote ID is the identifier of the switch, and the relay circuit ID is the identifier of the port. So, for example, if we have the switch here with just one VLAN 10 ID, and we have the computer in the network VLAN 20, in the VLAN 20, and also we have servers somewhere here. Then if the packet comes here, I mean the DHCP discover comes here, if we just send it from the VLAN 10 with the VLAN 10 as the gateway, VLAN 10 address as a gateway, we would never get back the offer message properly, because the server will see the GAD field with the VLAN 10 address, it would find improper IP address, then send it here, and then the VLAN 10 would never understand where to put it, because by default it disseminates the offer message in the VLAN 10, not in VLAN 20. They are not connected. But if we add those two parameters, the circuit ID and the remote ID, then the VLAN, then the switch adds to the packet, like I put SV1, two parameters. First, in the DHCP options, or in the DHCP protocol section of the packet, it would say, okay, the geadder is has the identifier of SW1, so it is a switch 1, the name of the switch, and then we've got the port. The circuit ID is G05. So please, on the back, please add those parameters here, so that the switch, when it gets the offer message, it would look here and understand that this offer should be sent here to the client on the port gigabit Ethernet 0/5. Yeah. So this is what it is all about. So the DHCP information option may be added by the IP DHCP relay information option, and then would indicate the remote ID, the suboption type, and so on and so forth. And the option would be like in binary, the identifier in binary, then the SV just the slot number and VLAN number, for example, 510. For example, the PV is the port number and VLAN number, and so on. So SPV, this is the slot, port, and VLAN number. The slot is used when the switch is a stacked one. So, for example, if you use the stacked switch on the access layer, then you should use either SV or SPV. And so how we actually configure the DHCP relay first at the 2300 series. First, we just enable the IP DHCP relay functionality. Then we configure the IP DHCP relay address, the actual address of the switch. Then VLAN 10 IP DHCP address, not DHCP, but IP address for VLAN 10, from which the information, the DHCP message will be sent to the server. Then also we should indicate the IP address at the VLAN, the access VLAN, where the endpoint will be located. And here on this access VLAN, we would write the IP DHCP relay enable. So we enable the DHCP functionality both globally and on the VLAN interface that will resend the messages. And so also we allow the VLAN number 10 on the trunk port, so that it may go upwards to the DHCP server, and so on. Yeah. And this is the example of the configuration of the option 82, the IP DHCP relay information option, suboption type custom. On 14 and 2400 series, almost the same situation. However, so here we create VLANs and then activate those VLANs. Then we are making the VLAN 10 and the address of the outgoing VLAN, and then the interface VLAN 20, the downside VLAN, where the endpoints will be situated and will be located. And then globally turn on the IP DHCP relay functionality, and then IP DHCP server address. We can have several IP DHCP server addresses, and in this case, the discover message will be sent to all of them. So it seems just for your comfort and just for your convenience, maybe two servers will be necessary so that you will have the backup of one with another. So this was the DHCP relay. And so we have also some protection for the DHCP protocol. The functions that are called, the functionalities that are called the DHCP snooping, and also the port security. I think that we'll need some 20 or 25 minutes for this chapter, and then after that I would propose to have the coffee break, but not now. Do you agree? Yeah, thank you. So first we will consider the DHCP snooping. What it is all about. So as I said, that DHCP protocol is not the most, to say the least, it is not the most secure protocol at all. So there are a lot of vulnerabilities and there are a lot of threats that are connected with this protocol. So let's try to look to one of the most popular things, which is the DHCP spoofing attacks. Could you please show an example of a DHCP server with option 82? You know, this is a very complicated issue. The option 82. In fact, you cannot configure the DHCP server that will understand the option 82 on our switches. So it is even on our routers, you would not be able to configure this. So this should be a separate installation. There are a lot of things, a lot of manuals, the internet, especially for the Linux machines and so on. But it should be the separate installation, separate program product, and our switches support the option 82. On the client side, but they don't support this option 82 on the server side. So, but what this would be all about? Yeah. For example, you have the DHCP server. Yeah, it has several pools, like pool 1, pool 2, pool 3. Usually the pools are identified by either the VLAN, then we will have just one pool, or the gateway address, which is the G address. So here comes the DHCP discover. For example, the G address 10, 10, 1, 5. Yeah, we understand that the pool number 1 is for 10, 10, 1, 0, 24. The pool number 2 for 10, 10, 2, 0, 24. And pool number 3 is for 10, 10, 3, 0, 24. If the gateway address is 10, 10, 1, 5, the server understands that it should go to the pool number 1 and select some addresses from the pool number 1. Yeah. And this functionality is totally acceptable on our switches, and they can work with this kind of functionality, no problem with it at all. But if we are talking about the option 82, For example, here we may say like that. So here comes the discover message with the geaddr, something like 10, 10, 1, 5. Yep, why not? But there is also option the remote address or remote ID, like switch 1 and port ID or circuit ID, like G05. Yeah. Here we understand that no pool is suitable for us, or it can be like 5, 10 here. So we understand that no pool is suitable for us. We need a special pool, like it will be the pool 4 with the network 10, 10, 4, 0, 24. Yeah, but it also should have these characteristics. For example, it should have the remote ID switch 1 and the ports range from 1 to 20, port ID range. And then if someone comes with this identifier and with this range of ports, then we will give them some addresses from this pool. But this option 82 should be supported on the DHCP server. It should be implemented there in their code, but not with ordinary DHCP pools. Usually we indicate this option as there are sometimes it is widely used by the internet service providers. How they use it. So I was thinking of an example configuration on the switch side. Let's have a look. So 14, no, it's not going like that. Yes, 52. I forgot my password. Just a moment. Okay, I'm searching. Where is it? Oh, here we go. Okay, so where is it? Oh no, it was DHCP relay. Okay, IP DHCP relay. Relay information option sub-option type either tier or custom. I think on the custom that will be all. Yes, but the format type, so either the external ID or so we can make the remote ID, which will be the actual identifier for the switch, not just name, but the some ID, like remote ID, switch number, something like that, and also format type option. So in here we may indicate something like the binary. I won't really help with that, but for example, if you SPV, then the if we say the SPV, then the slot port and VLAN numbers, it will be sent in the format like 0. So if we say the delimiter should be this one, then so if we say slash in the delimiter, so the port number will be sent something like the slot number 0, port number 5, and VLAN number 10. So this circuit ID will be sent to the DHCP server, and the server should understand what it is. Yeah. Yeah, something like that. And you may also use for delimiter the commas, dots, semicolons, and so on. Semicolons. Okay? Yeah. Not at all. Do you use option 82 often in your activities? So, DHCP snooping. As I said, DHCP protocol is not a secure one. Option 43 is possible. Option 66, I never tried it. Really, I tried to configure option 43. It is an education. And of course, this option 43 is used to give the access points the IP address of the wireless LAN connector, wireless LAN controller. Yeah, but we don't include it into the course because it's not a beginning thing. We mostly consider this topic in our Wi-Fi courses. Yes, option 43 is definitely possible, and option 66 never met it, but probably yes, probably we can do that. So As I said, no, not at all. As I said, the initial discover messages is sent are sent in a broadcast manner, in a broadcast way. So all the users of the network, for example, here this malicious user, which is called who is called Alice or Alice, call him like as you like. So everyone can get this message, and so the malicious actor can also make some actions, can reply to this message. Especially it can, or she can, or he can send his or her own offer. So here is the OA is the offer from Alice, and the OS is the offer from the server. And the Bob, who is the attacked one, will receive, will accept the first offer that he gets. So it may not be the offer from the legit DHCP server, but it can be the offer from the malicious agent. Then he, after receiving the offer from Alice, he sends the request message saying that, okay, I am accepting, this is the CADR field, I am accepting the offer from this guy, from this girl, so from this person, and the server says, okay, I will not give you the IP address. And Alice, when she sees this, she would reply with the ACK message saying that now, so actually, all the traffic from the Bob will go to Alice. So she is the default gateway, she is the DNS server, she is the she gives some address, and so she is the primary person the Bob will interact on the network. This is one of the attacks, which is called the DHCP spoofing, and it can also be the part of the man-in-the-middle attacks. So to prevent, also there is another kind of attacks, which is the DHCP poisoning, but we will talk about this a bit later. To protect from these attacks, we use the DHCP spoofing functionality, DHCP snooping functionality, and each time that each time that we hear the word snooping, we understand that there will be some bureaucracy involved. I mean that when we are talking about the snooping, first we separate the ports, and we segregate the ports into the trusted ones and untrusted ones. The trusted ones are allowing all the DHCP messages to move either on ingress or on egress. And the untrusted ports, they only allow the client messages, the message from client, on the ingress, and the server messages on the egress. We'll look how it works. So here you see that the red brimmed rounds are the untrusted ports, and this one is trusted ports. So as I said, that the untrusted ports allow the discover message, the request message, and also the decline message, decline and release messages. I mean the messages from the client, they allow that on the ingress, and the trusted ports allow them on the egress. What does it mean for the network? It means that the Alice will never get the discover message from Bob, and so we alleviate the threat of having the illegitimate offer from the malicious actor. Even if this malicious actor would like to make the so-called that it is like a spam attack when the malicious actor just turns on the message generator, the frame generator, just sending a lot of offer messages to whom it may concern, okay, or the offer messages they can send in the broadcast manner, as we said. So the offer message can be sent in a broadcast way as well. So if Alice wants to send those broadcast offer messages, it won't pass through the untrusted port because the offer is the message that is intended to be from the server, and the trusted port and the message from the server will also only be allowed on the ingress of the trusted port. So why do we have the trusted port? After all, it means that we trust that behind this port there is a server installed, not on any other port, but on this port. Of course, there could be several trusted ports on the interface, so that's okay. That is why this measure will protect us from the malicious actors on the network. As well, there is some bureaucracy, as I said. Is there any example of the daisy chain switches with that scenario? To be honest, I wouldn't say that the daisy chain would be very effective in this issue. But as far as I understand, so daisy chain is, yes, trust should be trusted. And so if I understand it correctly, for example, we have something, the network for something like SCADA, or network sounds like the outer CCTV, like we have a series of switches located somewhere out there, and then one distribution switch or pair of distribution switches located somewhere inside. And so we connect this with something like in a chain manner. Yeah, so do I understand it correctly? Is it? Yes. Okay. So yes, we should trust all the trunk ports here or the general ports here, because if the ring goes down here, we should have an exit to somewhere else. Yeah, but in hierarchical model, we only use the DHCP snooping on the access switches. We don't use and we don't recommend it on the distribution switch, as the distribution switch should already be protected. Yeah. So this is a trusted ports, trusted port, trusted port, trusted port, trusted port, and these ports, all the downlink will be untrusted port. So here we go. And for daisy chain, these the downlinks will be untrusted ports here, and here all the ports should be trusted. As you don't know where the DHCP offers from the server may come, because if you have the bridge out here, then the offer would come from this side, and if this port is untrusted, then you will have a problem. But it's a very interesting idea. That so that I think so. Like to say a bit more about our internal like kitchen, like we say it in Russian. We are now preparing together with our technical support department. So the guys from the technical support from all the departments, they are preparing right now the comprehensive design guide for all the features that our switches have. So that will be the comprehensive guide for the deployment of our switches, of routers, everything else in the just carrier network, in the wireless network and the voice network and so on and so forth. So we are working on that as well. And then I think in half a year time, so in the quarter three of this year, we should present a course on the design as well. So it will be based on this thing, and then I think it will be an interesting, but I don't know whether we'll have time to translate it in English, but I think that by the beginning of the next year, we would present a course in English as well for the design of our networks, and there we would discuss all these issues comprehensively. In this case, as I said, there's some bureaucracy is involved. So when the discover passes through the untrusted port, the switch makes the so-called DHCP snooping binding table, where it fixes the port, the VLAN, the MAC address. The MAC address is taken from this client MAC section of the DHCP data. The IP address is set to all zeros, and the least time is set to 120 seconds, so 2 minutes. It is quite enough for the acknowledgement to be sent. Then here goes the offer, then goes the request, and then when the acknowledgement arrives to the trusted port, then it also the acknowledgement is also overlooked, and then we say, okay, now what is it for? Whom is it for? It is for this MAC address. Okay, we have this MAC address on this port. Fine. Now it has the IP address, so it states a new IP address, and the least time. So the least time is stated here. After that, we understand that on this port we have so behind this port we have the endpoint with this MAC address, with this IP address for this number of seconds. And when the list is received, when the ACK is received, the list is stated like 600 in this example. Then it goes like 599, 598, and so on and so forth, right down to 300. And when it is 300, another request is sent on this port and received on this port. Another acknowledgement is received here, and so it updates to 600. Yeah. So because the IP address is updated via the DHCP, we got the DHCP protocol in here. So after that, the switch knows that, for example, if someone else on some other ports presents is trying to introduce himself with this MAC address, then it will be the failure, because we know that this MAC address is stated on this port. Or if someone else is trying to present the packet with this IP address on some other port, then we will also drop the package or drop the packet, because we know that this IP address is stated on this port, on this untrusted port. So this DHCP snooping information provides a lot of DHCP snooping feature provides a lot of information for other security function of the switch. So how should we configure the DHCP snooping on the switch? Like first we switch the IP DHCP snooping globally, then we switch it on the network, or on the VLAN, and then all the ports that are connected to this VLAN, all the ports associated with this VLAN, they automatically become the untrusted ports. So you don't have to configure the untrusted port manually. They are all untrusted by default. And so we may go to some, for example, the trunk port, and set it as IP DHCP snooping trust. So we set the trusted ports manually, and all other ports are untrusted by default. And we also have the command, the diagnostic command show IP DHCP snooping binding, that is showing us all the bindings of the MAC address, the IP addresses, the remaining lists. The type learned means that this address was received by the DHCP and was fixed here by the DHCP snooping function. There also may be static IP address if you configure them manually. In 14.2400, there is also a feature that IP DHCP snooping is also turned on and enabled on the global level, so it is in a global configuration mode, but the IP DHCP snooping on the VLAN is switched on in VLAN configuration mode. So you should go to the VLAN, so VLAN 10, and then switch on the DHCP snooping there. Also, the trusted port is switched on with two commands like port security state trusted and set port uplink. As the 1400, 2400, and 3400 switches, they think that they can only be the so initially they were created to be the access switches. So all the product line they initially was as a cheap alternative for access switching. So that is why they think that the only way that the DHCP DHCP message may come to them from the server is that from uplink. So this is the set port uplink. So if you want to make this port untrusted again, so you should say the port security state untrusted and set port downlink. Okay. So these were the attacks. So the DHCP spoofing attacks is aimed at the client. But there are also two kinds of attacks, the DHCP starvation attack and MAC poisoning attack, that are aimed at the server itself. How they are implemented? The Alice, like any malicious agent, may connect to the network and then start sending a lot of messages, for example, discover messages, with changing the source MACs. As I said, the DHCP protocol doesn't have any verification means of verification. So any discover with any MAC address is the legitimate client for the DHCP server. It doesn't have any protection in itself. It doesn't have any inner protection instruments. So if we, for example, if we say so several thousands of these discover messages in a very fast way, then the server will go out of IP addresses, and then it will pass only. Okay, it will stay. It will stuck. It will get stuck, so it won't give any IP addresses, and so the legitimate clients on the network wouldn't be able to obtain addresses, and the network will go unworkable. Will stay unworkable. The same attack may also disbalance the switch. As we all know that MAC address table is limited. For example, at 2300 series, it is something like 16,000 addresses. That there are only 16,000 entries that it may contain. In the 3300 series, there are around 32,000 entries, but still, it is not really big. It also can be spammed by these things. As for the switch, any new MAC address represents any new client. it presents a new class. So if the malicious client sends some several thousands of these discover messages, they all will be learned on one port, and then we will have some problems if the MAC address table comes to its end. It cannot hold more entries, so we all know what happens. The switch will go in the hub mode, so it will send all the it will send all the frames that it receives on any ports, and it will send them all to all other ports. So it will make the situation even worse, not any better. So to protect the switch and protect the DHCP server from these kind of attacks, we will employ the port security function that limits the number of the MAC addresses that can be learned on the port. Also, it limits the frequency of the learning of the MAC addresses on the port. So, for example, the first we should do is limit the number of MAC addresses that can be learned on the port. This is done with the command port security max. So max is the maximum number of the MAC addresses that can be learned on the port. Maybe 2, maybe 3, maybe 10. It depends on the kind of the port. So if you have the ports for the task user who's got only the desktop computer and the IP phone, then 2 MAC addresses for the user will be quite enough, more than enough. So if the user disconnects his own computer from the network or IP phones on the network and tries to connect some device that he brings with himself, so the port will be blocked. So very reasonable issue, very reasonable, very reasonable measure. So then the port security mode, meaning how will we learn the addresses and what will we do with them. The learning mode max addresses means that you may learn only so many addresses that you indicated the max command, but these addresses may age, and after aging one of the addresses, another address may be learned. So this is a very democratic way. So you don't actually restrict any addresses, but you restrict the number of the addresses. Also, we have the secure mode. If you say the secure mode, that it erases, it deletes all the addresses that have been learned on the enter in the MAC address table behind this port, and it learns new MAC addresses, but not more than is permitted in the max command. Also, we have the lock mode. The lock mode just fixes what it is on the port. So if there are 5 addresses learned or 6 addresses learned, then the lock just fixes the kind of addresses. They cannot age, so they will be preserved like this, and new addresses cannot be learned. So we just have the fixed picture. Also, there is a violation mode, the so-called violation mode for the port security. This is what we do with the frames who have the unlearned MAC addresses. For example, the discard is the action by default. It means that we will just discard this frames without any further actions. If there is a discard shutdown, it means that the packet or the frame will be discarded, and the switch will go into the shutdown state. Well, not really shutdown, but air disable state. And the discard shutdown VLAN means that the frame will be discarded. the port will be put into the air disabled state, and the VLAN will be stripped out of this port. Namely, the port will go into VLAN 4095. And for the secure mode, there are two. So the secure mode is the same, like is very alike with the Cisco's sticky mode for security, and there are two modes for this mode, two submodes. The permanent mode means that we will the address will be stored in the startup configuration, and delete and reset means that address will be stored in the running configuration, but it will be deleted when the switch is reloaded. So this is how these addresses look like in the configuration, like MAC address and so on and so on. And the secure word represents the situation that this MAC address was learned with the port security function. So these are just some examples. And also, if the MAC address is learned as a result of the secure port security operation, in the MAC address table, it will be also marked as a secure address. So it was learned securely. With the 24 series, so 24, 2448, and 34 series, I think, yeah. So the port security, the number of learned MAC addresses is limited by the command port security MAC limit. Then we have 4 modes for learning the MAC addresses, but you know that secure related and secure permanent, they just made the separate mode. So MAC addresses the same as in 2300 series, secure delete reset and secure permanent mode the same as the 2300 series, and lock also the same. Then port security violation, a bit different. It is more like the Cisco logic. Protect means the frame is discarded. No one knows, so no indication of the process will be sent to the administrator. Restrict means that the frame is dropped and the special warning will be sent to the administrator. It will be also syslogged. And discard shutdown means that the frame will be dropped and the port will be put into the air disable state. Yeah, this is what I was going to tell you about in this chapter. Sorry for delays. I would propose that we have. Do you really need 20 minutes for coffee break, or 15 minutes will be enough? So, and last topic for today is the access control lists. One of the most difficult topics in our course. In fact, we got 2 very difficult topics. That is the access control lists and the spanning tree protocol. Usually they are the most difficult. I don't know why, but still, if we judge on the feedback from our customers, then they are the most difficult ones. So let's discuss the access control lists. What are they doing and what should they do? So yeah, here we go with so. In fact, it is a header in Russian. Just forgive me, I will change it. But I think they have changed it in the student guide, but forgot to change it here. Still, when we're talking about the access control lists, we should understand that we are checking the fields. The access control list is the collection of the ACEs, which is the access control entries. In other words, they are called rules. Yeah. And each rule is intended to check either one or several fields in a packet. Initially, so when the access control lists only were invented, they were checking just one field. It was the source IP in the layer 2 header. Afterwards, the people invented other kinds of access control lists, which are called the extended control lists, and the first category was called the standard control lists. The extended access control lists are checking several fields in one setting, in one rule. For example, you may check the source IP address and destination IP address, as well as source port and destination port. Sometimes you may check the source MAC or destination MAC, and so on and so forth. However, and also the protocol that will be used in layer 4 and so on. For example, if you use the Cisco, Huawei, or HP control lists, you know that there are common constructions like IP, like permit IP any, or permit TCP any, and so on. We have alike structures here, so we will look at them. But because we have the switch, the first thing we check in the frame, the first thing the switch checks in the frame is the destination MAC, the source MAC, priority class of service, VLAN ID, and so on and so forth. So in switches, we may employ the ACLs on the L2 level. They are called the L2 ACLs or MAC-based ACLs, and the IP-based ACLs, AP-based. So the IP-based ACLs are working on the levels layer L3 and L4, and the MAC-based ACL is working with all the fields in the layer 2. So this is a really powerful tool in order to filter traffic and to make the network more reliable and to make the network more secure. So yes, the standard access lists, they are working only on layer 3, and the extended access lists working on the layer 3 and layer 4, and also on layer 2. This is very important. As we have the switch, it is also very important to bear in mind that the access control lists on a switch, they are implemented on the ASIC, not on the CPU, like it is done usually with Cisco routers, for example, and in our routers as well. But they are implemented in the ASIC, so they are very fast, they are very reliable, and so they are give me a minute for the presentation update. Okay, so when we're talking about how the ACL works, we should mention that as I said, the ACL is a collection of the ACEs, in other words, a collection of rules, and each rule is, so each packet is being checked against the rules until some rule fires. There is the small term, the rule fires. It means that the packet has met all the conditions of the rule, and then the rule should be implemented. The rule itself consists of two parts. First is the condition, and then the action. So each packet is checked against all the rules, but until the first rule fires. If some rule fires, then the action is undertaken, and the packet is either sent or discarded. When the rule fires, the packet is not checked against all other rules. So the rule may fire just one time. And this has very interesting consequences for the packet and for all the functions of the ACL. For example, we have some packet, and then we check it against some rules. So the first rule, if it satisfies the first rule, then we check if the action is permit. So there are only two actions in the ACL. First is the permit, and another is deny. Permit action just sends the packet along. The deny action just discards the packet or the frame. It depends on what we are working with. So permit action is okay for the packet. Deny is the discard the packet. So all the rules are checked. However, what happens if no rules, if none of the rule fires? If no rule is working, so the packet satisfies no rule, then there is a very interesting moment that is called implicit deny rule. Implicit deny means that if the packet satisfies no rules, it must be discarded. So that is why implicit deny. All the packets in the ACL are implicitly denied or explicitly permitted. So the implicit deny rule means that it is not written, it is not stated anywhere, it may not be in any configuration, but it works and it is there. You should always think about that, and you should always remember that the last rule will be deny any. So it is clear, deny any. Yeah, the last rule is deny any. So if no rule is satisfied here, so the last rule will be implicit deny. Okay, so the ACL is working only when it is applied to an interface. In MAS switches, in OLTEC switches, we have two kinds of interfaces where we may apply the ACL. First is the physical interface, literally the port. And second is the SVI interface, that is the VLAN interface. Yeah. So we apply it either on physical interface or on SVI. Not all the ACLs may be applied on physical interfaces, but almost all of them may apply to the SVIs. But, for example, in 2300 series, the ACLs may be applied, the extended ACLs may be applied to physical interfaces on inbound direction and on outbound direction, but only on the inbound direction for the SVIs. So all the SVIs have only inbound capability. But sometimes the standard ACLs, they cannot be applied to the physical interfaces. So there are limitations. Also, as I said, there are two kinds of ACLs in terms of direction, either inbound ACLs or outbound ACLs. For example, here, the packet may be filtered here on the ingress of the switch DSTS W1, destination switch 1. And this will be the inbound ACL, yeah, or on the outbound on the egress of the destination switch 2, and this will be the outbound ACL. When you create the ACLs, on where you place the ACLs, you should remember the direction of the ACL. The inbound ACL will not filter the outbound packets. So if you have only the inbound ACL here, you may have both inbound and outbound ACL, but if you have only inbound ACLs, all the outbound traffic will go free. This ACL will not filter anything. And if there is only the outbound ACL here, all the incoming traffic will pass free. So there won't be any filtering, there won't be any trouble with this traffic, for this traffic. As I said, there are three kinds of ACL. First is the IP-based, then the MAC-based ACLs, and then the management ACLs. Management ACLs, they are intended only for the management traffic, which is protocols like SSH, Telnet, SNTP, HTTPS, HTTPS, and so on and so forth. So these ACLs, they are not applied to any interface. They are applied only globally to all the switch and to all its interfaces and to all its lines mainly. So IP-based ACLs and MAC-based ACLs are for layer 3 and layer 4, the IP-based ACL and MAC-based ACLs for the layer 2 header. The IP-based ACLs, they can be either standard ones or extended ones, but MAC-based ACLs may be only the extended ones. There are no standard MAC-based ACLs. So how we make the IP standard ACL in 2300 series? So here we have the command IP access list. We have a name for this access list, then the action deny or permit, and then any address. Here should go either IP address or network address, so IP with a mask. Here we use the subnet mask, not the wildcard masks like Cisco do in the standard ACLs, but the simple common subnet masks. So if you, for example, if you want to deny the traffic from the network 10.10.10.0.24, you put here 10.10.10.0.24 without any more trouble. So in Cisco, like, you would have to use them to employ the wildcard mask, and it will be like 10.10.10.0.0.0.255. So we also use the wildcard masks, but only in 2300 series in extended ACL. But for standard ACLs, we use the simple subnet masks. In 1400 series, there is one very big distinction. In this case, for the standard ACL, you may use both IP source address and the IP destination address. This is like an exception. In all the literature and all the training courses, all the producers say that we have only for standard ACL, we are checking only the IP source field. But here you may also check the IP source field and IP destination field. There is also one distinction on the ACLs on the 1400 series and the 2400 series. You may have only one ACE per ACL. And that is a very interesting feature. Let me show you how it works. So we go into the 1400, admin. So let's make the ACL. For example, something like IP access list standard. Then the number will be let it be 500, because the numbers are from 1 to 1500. Then description test ACL, so to understand what we are doing. And here you may indicate just one ACE. I mean, just one rule. Not 2, not 3, not 10, just one, not more than one. However, okay, let me see. So deny, for example, the traffic from the network 10, 10, 10, 0, 24, here 24, 24, 2, 10, 10, 20, 0, 24. Yeah. Okay, deny here. And then you may enter another rule, another condition that would say permit from 10, 10, 20, 0, 24. And yes, let's check if we have this ACL already in the running configuration. Do show run. Yes, we have it. It is a deny 10, 10, 0, and so on and so forth. Yeah. So let us say that permit the traffic from 10, 10, 20, 0, 24 to 10, 10, 30, 0, 24. Yeah. So we entered in the same access list, we entered two conditions, we entered two rules, but no one said us there is a mistake, or no one said us that there is an error. So I think we are doing some legitimate thing. But pay attention to this. Do show run. Okay. The second rule overwritten, overrode the first rule. So the first rule was like this, and then they entered another rule, and so it is now here in the configuration. Only one rule. And when you are entering the next rules, it will overwrite the previous ones. So this is the what to. So this I wanted just to draw your attention to this, because it is a very important, and a lot of students of mine, they are complaining that they have done such thing. So I did this thing myself, for example. Yeah. So these are the examples of the standard access lists. Here it has permits or whatever. And let me show you one more thing for the 2300 series. Admin 1, IP access list, which is just access list. No. IP access list name standard ACL. No, access list standard ACL. Deny 10, 10, 1, 10, 10, 20, 0, 24. Yep. And then IP access list standard. Permit 10, 10, 10.0.24. Do show access lists. Yeah, we have several rules out here. But what if we want to put some condition out here before the first rule in the whole access list? Let us try IP access list standard ACL deny 10.10.5.0.24 and that's all. So this is very unfortunate thing, but we cannot change the order of the rules in the standard access list in the 2300 series. Yeah, that's what I wanted to show you. And if you want to, for example, change the order, then we should erase all the access list and then make it again. So if we say the do show run on Cisco, I don't remember whether we have the proper when we can change the number of lines in the standard list, but I think that on the standard we can change it, but we can definitely change the number of the order of lines in the extended control list. But here, just so if you want to really to change them, just copy them from the running configuration, and then Notepad is everything for us, you know. So, but when we're talking about if we're talking about the extended control lists, we'll look at them now. Then we can change the order. How can we do that? For example, okay, IP access list extended ext ACL. Yeah. So you see that we are going to the access list configuration mode. Then we may say like something like deny 10.10.50.24 deny IP any 24 any deny yeah, here we can use the prefixes, but we should employ the wildcard masks in the extended ACLs. 10.10.5.0.0.0.255 any. Yeah, here we go. Permit IP any 10.10.20 0.0.0.255 to 10.10.30 0.30.255. Yeah, and so when we try to look for this ACL in running config, do show run. Then we will see that we have the so-called AC priority 20 and AC priority 40. These are actually the number of lines. So if I want to put some condition before or after, so of course, if you just use the condition or enter the rule without stating the AC priority, it will be the last one with the increment of 20. But if I want to put some condition before the first rule, for example, deny IP 1010 IP any 1010 50 000 10.5 any. I would say AC priority 15. And so it will go up here. Wait. I just used this. Oh no. Oh no. Yeah. Here we go. Here we go. I should state the do access exit. What happens after exit? Do show run. No, we don't have it. Why? As we first employed this ACL. Just use the same address. Why would I do that? IP access list extended ACL. One more time. Permit IP any 1010 50 0 00255. Is priority any AC priority very, very good question, Erna. I will come to this right now. I say priority 15. I'm just showing you how to change the order of this. Yeah, now it is working. You see, I just used the same network, so it was like something else. Yeah, you are right in asking that, and this is another topic for us. So what about deny a complete network with low priority and then allow some hosts from the same network with the high priority? This can be done with the number of with this ACL, the AC numbers or AC priorities. As you see that we cannot, we can't. Sorry, my English. The ACL checks for the rule just one time, so it matches the packet against the rule just one time. If the rule works, then we are in trouble. So it won't check more than it already has checked. So let me draw it here. Draw it here. So the rule 1. 10, 10, 10, 0, 24. Deny. Yeah. And then we want to permit some hosts from this network. It will be rule 2. Permit 10, 10, 10, 5, just 25, 10, 10, 10, 5. Will this one work as we intend? No, it won't, because the address 10, 10, 10, 5 belongs to the network 10, 10, 10, 0, 24. And so if the packet from this network, from this host arrives, it will be denied by the rule created for the network. That is why it is very important first to put the rules with the less range, or first you should go make the rules for the hosts, then the rules for the smaller networks, and then the rules for the bigger networks. If you reverse the order of the rules, that's fine, that will work. So that's what I was trying to say. The first should go the smaller rules, the smaller packets. I mean the rules for smaller ranges of addresses, and then should go the rules for the bigger networks, and then for even bigger networks. Yeah. Otherwise, the ACLs will not work correctly. Yeah, this is called from small to big, or from the private to the common, something like that. So from the small to the big. First, smaller addresses, smaller networks, and then bigger and larger networks. Otherwise, as you see, it just won't work. Thank you very much for the question. Okay, so if we use the extended access list, that's what we have seen right now. Also, in the if we want to apply the ACLs, so we want to assign the ACLs. As you know, the ACL is not working without the application to the interface. They will just peacefully sit within the running configuration, doing nothing. And if we apply, but how we apply them to the to the interfaces? In 2300 networks, there can be only one interface per direction, not one ACL per interface per direction. So, for example, there can be just one ACL on inbound direction and one ACL for outbound direction on one interface. And if you are talking about VLAN ID interfaces, VLAN interfaces, then only one ACL inbound. So one incoming interface, one interface for incoming traffic, because the essence of the SVI is so that it doesn't matter what is the outbound. The ports can communicate between themselves, but and the outbound traffic can be controlled. But on physical interfaces, you can control both inbound and outbound traffic. However, on the 2400 series, you may have several ACLs inbound and several multiple ACLs inbound and multiple ACLs outbound, because their ACL contains just one ACE, just one rule inside. That is why we compensate for that with the several ACLs per the interface. If you want to apply the ACL to the interface in 2300 series, then you should use the command service ACL, then input or output, and the service ACL input for SVIs, for the LNIDs. Also, the statistics for the ACLs on the 2300 series, it is not automatic. You should switch it on manually. And on 2300 switches, is 2300 switches, there is not excessive processing power, so you may use only either the statistics per physical ports, which is access list statistics ports, or the statistics on SVI, which is called the statistics VLAN. Either this or this. But on the higher models like the 3300, 3500, 5300, and so on and so forth, then you may use both statistics for both ports and for VLANs. So that's the kind of example of how this thing works. Like first access list statistics port. So it is the 2300. We want the physical port statistics. Then IP access list extended IP. Then we permit ICMP echo requests, like permit ICMP any IP address or network to any from any IP address or network to any IP address or network, echo requests and any messages in the reply. Then permit TCP from this host. These are the 4 zeros represent the host here to via any port with any port, any TCP port, I mean. Then to any network, not any, to the network 10.2.1.24 with on the port number 80. So this is the HTTP protocol. AC priority 20, here is ART priority 20, here it is 40. Then deny UDP any 67, any 68. This is the number of ports. I mean the port numbers, 67. So we deny all the communication from the server to the hosts, to the clients, and also permit IP any. Why so many any's? Why so many any's? The developers of the ACLs on 2300 series, they, I think, they thought like this. Okay, we got the IP here. So that means that we may use any protocols, just any protocols within the IP realm. So it doesn't matter whether it is UDP, TCP, and so on. But we have 4 slots. Usually, if we deny UDP, we have 4 slots. First IP source port, then source destination IP, and the destination port. We still have 4 slots. So if we say IP here, we may deploy any ports. So we don't really need 2 slots here. So let's use them. And so the first 2 slots, they are MAC address. This is the IP. This is the L3 interface, the L3 ACL. But still, here goes the source MAC address, then destination MAC address, then source IP address, and then the destination IP address. So the first 2 any's, they are MAC source and MAC destination. In the forthcoming models like 230008 or 230024 or 48 and so forth, these thing changed to just to permit IP any without any perversions like you see here. And the common service ACL input IP just applies this ACL to the interface. What about the extended IP access list in the 2400 series or 1400 series? The same thing, only we know that only one rule or one AC can be deployed per one ACL, but then can be numerous ACLs on the interface. We will see how it works right here. Also, the ACLs represented, the extended ACLs, they are represented by the numbers from 1001 to 65, 535. But the number doesn't automatically make the ACLs standard or extended. You should also write the destination, whether it is extended or whether it is standard ACL. and the application command is the IP access group, like in Cisco. So we are doing like this. So extended list, extended number of the ACL, permit ACMP any. That's simple. We are allowing all the ICMP traffic. Exit another ACL or another ACE. IP access list extended 1002. Permit TCP, host, and so on. But here is the difference. Also, one more difference is for the extended ACLs. See, first goes the protocol, like in 2300. Then goes the abbreviation for the address. Here we may use the host. So this is the IP, the IP source. Then here goes the IP destination, and then goes the port. Where is the source port? Here it is just omitted. If you don't use the port here, don't write any, or don't write any something here, don't put any here, just omit, just skip the place, just skip the port for the port number. Yeah, and the packet count command activates the statistics gathering for this ACL, whether it is located on the physical port or it will be located on the SVI, so the statistics will be gathered. The packet count is for the statistics. And then you may indicate those ACLs on the port, like IP access group 1001 in, 1002 in. In fact, it doesn't, and here is the main difficulty with the 2400 series. It doesn't matter how you will place the ACLs on the interface. They will be automatically arranged in the ascending order. So you may put any ACLs here, and then will sort themselves out and then be applied to the interface in the extended order. Like you may say first 1005, then 1003, 1002, and so on, but they still will be like 1002, 1003, 1005. So if you create the ACLs with the numbers, make gaps between them so that maybe sometimes in the future you would need to place some ACL between them. So don't use the 1.1, 1.2, 1003. It's better to use 1001, 1010, 1020, and so on and so forth. So this is to be done in advance. And also the MAC access lists, MAC-based. In 2300 series, we just make it MAC, not IP access list, but MAC access list, and make it extended. They are only extended. There cannot be any standard MAC-based ACLs. And so we deny any ACL, any MAC address, any source MAC, any destination MAC, so from any source to any destination, and then goes the protocol number. And the protocol number is the ether type field. So we're checking here the MAC source, MAC destination, and the ether type field. Here also we may permit the traffic from any source to any destination, but only with the priorities of 4 to 7. So there will be 4 here and the mask 3. Also, we deny traffic from some host. Here we also use the wildcard masking. So this is the MAC address, and all the zeros indicate that this is the host. We may also permit or deny traffic from some vendor. That will mean A, B, B, C, C, and then the all zeros, and the mask will be 0, 0, 0, 0, 0, 0, 6 zeros, meaning that this part must be exactly the same, and then there should be FF, 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 so all ones, representing that this part may go as you wish. So any options, any variants like you want. So this will be the sorting by OUI. So also permit any, just the usual thing for the last rule if the previous rule is the deny, so that we don't get trapped by the implicit deny condition, and then service ACL input MAC on the interface. Okay, then the MAC address, MAC access lists on the 1400 are also configured like starting from the MAC word, MAC access list extended. Nothing to worry about. We also have the IP time-based ACLs. This is another class of ACLs, as I think, but they are within the IP-based ACLs. So the idea is some ACLs may work only in a specified time. So where they might work, start working from the certain time, or till certain time, or in the time frame every day, or on certain days. For example, you may set priorities for system administrators, or just like in our example, we are prohibit using the internet to one group of people from the network 192.168.20.24 on all working days from 10 to from 9 in the morning till the 6 in the evening. So how we do that? First, we make the work time range. Time range we call it work times, and it will be periodic. So it will start every day and every week. Then Monday 90 to Monday 1800, like the military people say. Then or to the Friday, and then exit. So on all the weekdays, this time range will be working. And now we compose the time ACL. Time-based ACL, we call it the work time ACL. So IP access list extended work time, deny TCP. Our goal is to prevent them from using the port number 80, as it is not secure. So let me say that the people from this network to any on any port to any direction by the port number 80, and the time range will be work time. So all the working days from 9 a.m. to 6 p.m. Then permit any, so that it doesn't ruin any other traffic. And then we put this ACL, we apply this ACL in the input direction on some physical interface. The time-based ACLs, they are running only on the physical interfaces, not on HVIs. So, and the last thing I would like to tell you today is the management ACLs, management access lists. They look something like that. So they are created in a global configuration mode, and they are applied in the global configuration mode. So there is one tricky question in the test that is that says what interface should the management ACLs be applied to. They are not applied to the interface. They apply to the whole device in a global configuration mode. So that is why they not that is why, but they go like this: so management access list, some name or some number. This is for the 2300 deny service or permit service, whatever you want. So deny service table that the service will be permitted. Deny receiving the management traffic on the interface gigabit Ethernet 01. Then permit the management traffic from the network, probably where the system administrators are located, and then we apply this management access list by the command management access class and the number of this ACL. In 2400 series, we use the command authorized manager IP source. Then we say what will be the network that we allow the traffic from, and then the interface where it should come, and then, for example, VLAN in which it should come. Also, we may employ the service command and then state whether we allow HTTPS or Telnet or SSH or something like that. Okay, and so there are several diagnostics commands, so we just seen some of them. My favorite is this one: show access group interface and the interface on the 1400 and the 2400 series. This shows the number of the access list, the name and description of this access list, and the rules that are applied on the interface. This is also very interesting feature, and it shows what is already applied on the interface, and so it gives us the bigger picture than just seeing the ACLs in the show run mode. Yeah. Okay, that's all for today concerning the theory. Now I would like to propose you to have a lunch break. I think you deserve it. Like here you are, treat yourself nice. So we're gonna have a lunch break till what will it be? At 14 Belgrade time. Oh no, 2 o'clock. Oh, so right now it is 13. Yeah. Bon appétit.